Hello, it's me again. So I'm gonna make a video about forces in two dimensions, meaning like when the applied force is acting at an angle. Okay, and this is gonna be part two of the forces at an angle. So I'm gonna start on page 34, I think it looks like. So I'm gonna do number 48. Before you start, you always have to draw a free body diagram, and you also have to write your equilibrium statements. So I have a wagon, okay, on a surface that has a mass of 20 kilograms, which means the weight is 200 newtons. Okay, and it's being pulled at an angle. Okay, so this is 50 newtons, that's the applied force. Okay, and the angle is 45 degrees. The coefficient of friction is 0.16, that's kinetic, which means we're moving. Find the acceleration of the wagon. So now when it says to write the equilibrium statements, that's basically saying write F net equals ma, both in the x and the y direction. So I'm going to do it start with the x direction, but before I do that, I have to do my friction, my Fg or mg. Okay, now we have to think about, is the Fn the same as mg? Because for everything we've done so far, for most part, except for the elevators, the mg was always equal to Fn. Is that still true? Okay, well, if you think about it, the Fn is just how much support you're requiring from the surface you're sitting on or you're moving on. In this case here, it looks like this Fa is pulling forward, but it also has a component that's acting up. So that's going to contribute towards the Fn. So mg, which doesn't change, looks greater than Fn. So Fn has to be smaller. In other words, when you're pulling at an angle like that, the surface does not have to provide as much support. The surfaces are not pressed too hard against each other. All right, so I'm going to try to do the statement in the x direction. So it looks like Fa has a component contributing to the right, which is Fa cosine. It's this component here. Right? So I'll draw it on here and I'll erase it. It's this one here. So if you look inside this triangle here, this component is Fa cosine of 45 minus, there is a force of friction holding you back, and you're moving to the right, so the acceleration is to the right. The other equation that I'm going to write is in the y direction. So this object never accelerates, never actually moves up and down, so which means the F net equals ma in the y direction translates to, well, the forces up must match up with the forces down, so which means Fn plus the y component, this here, of Fa sine 45 equals whatever is acting down, which is the mg. Okay, so I start with that, and then it's asking me to find the acceleration. Well, the acceleration appears in the x direction, in the x statement. So I'm going to start here, and if I'm missing anything, I'll just go get it from the other side. Now the Fa, this is 50 cosine of 45 minus, now I don't have friction, but friction is mu Fn. So I have the coefficient of friction, which is 0.16. I don't have Fn, so which means I go on this side, ask for Fn, get it, and bring it back here. So Fn plus 50 sine of 45 equals 20 times 10, which is 200. Now, once I get Fn here, okay, get a number here, bring it, put it in here for Fn. You have 0.16 here. Now you have your friction, and I have the numbers here. So the Fn should be 164.64, and if you plug all that stuff in there, okay, you should get an acceleration of 0.45 meters per second squared. So I'm not doing the calculations because that's the easy part. Now I'm going to do the one below it, but I do the work. I'll do the work on top. So I'm going to leave the same picture. Now this weighs 15 newtons, so that's the mg, which means the mass is 1.5 kilogram. And by the way, when you finish with this triangle, make sure you erase these forces here. All right. So it pushes down. So instead of pushing into it, we're going to push from here. Okay. You don't want to have the arrow for the force going into the object, but it's always away from the object. And this angle here is 60 degrees. Okay, and FA is 100. Determine the acceleration. So in this case here, if this is my mg, if we think about that conceptually, the Fn should be bigger than the mg. And the reason for that is because when you push in at an angle like this, you're pushing down on this object. So the contact is tighter, which means now the table or the floor or the ground has to support the mg, and it has to support that y component of Fa. So I should have a force vector here for Fn that's longer in size than the mg. And I think I'm ready to go. So the acceleration is happening in the x direction. So I'm going to write Fa cosine of 60 minus the force of friction equals ma. That's my F net equals ma in the x direction. So this is going to be 100 cosine of 60 minus cosine of 60 is half. Now the force of friction I don't have, but I have the coefficient. So which means I have to go to the y statement and get the normal force. The mass is 1.5 times the acceleration. So here's my statement in the y direction. The up forces have to equal the down forces. That's like a short version of saying F net equals ma in the y direction. So I should have Fn acting up equals the y component of Fa, because this is pushing right and down. So it's going to be Fa sine of 60 plus the mg. And that should be 100 sine of 60 plus 15. Now once you get your Fn, which is 101.60, you put that in here, okay? And then you can do the math and solve for the acceleration. It should be 26.56. All right, next page. We're at number 50. Okay. All right, Superman is pushing down, okay, on the trunk lid of a stalled car with that much force. So this is my Fa basically, okay? And the angle is 40 degrees, so I'll change that to 40. The car weighs 9,800 newtons, which means it has a mass of 980 kilograms. So I'll put the weight of it here. Now, it's the same picture as before. So I'm going to just get rid of this. Okay, because you're not supposed to have the components of the forces. And it should be the same as before. Now, it says, assuming it starts from rest, how long will it take? So it's asking for time. So which means we have to use the kinematics equations. But between the kinematics equations and the F net equals ma, the acceleration is the link that goes back and forth. So right away, I need to find my acceleration. So I'm going to do my statement in the x direction. Now ff, I'm just going to write it, skip a step and say that's mu Fn equals the mass times the acceleration. Okay. Now I'm going to need Fn because this is given. That's 6786 cosine of 40 minus 0.23. I have to bring this from the y direction, and the mass is 980 times A. So here I do Fn, forces acting up equals forces acting down because the object is not moving vertically, equals Fa sine of 40 plus mg. And if you do this correctly, you should get an Fn that's equal to 141,061.96. So you take that, put it in here, and you should get an acceleration equal to 1.98. So once you have that acceleration, you also have the v0 equals 0 meters per second. You have the delta x, displacement, which is the same thing as distance in this time, and we're looking for time. So we have to use the one that has the time square. So delta x equals v0t plus 1/2 at squared, and the time should be 3.17 seconds. Okay, so we're looking at 51. All right. Now we're pulling, I guess, right? Yeah, it's pulling a sled at an angle. And we're making a 50-degree angle. Now, if you're pulling up, the Fn should be smaller than the mg, because part of the applied force contributes to supporting the object. So this is my mg, right? If the pulling force along the handle is 40 newtons, so my applied force is 40 newtons. Okay, how large is it? How large a force is actually moving the sled forward? So they're looking just for, well, what force, what part of Fa is helping you move forward? So that's just going to be, you have to do Fa cosine of 50 degrees. All right. You want to come in the video? Come on. Jeff here wants to interrupt.
What are we working on?
Go ahead. Say hi to the crowd. Now you can leave.
Okay.
It's 5A, baby. Let me see what you do.
All right. So we find the x component. So that's 25.71 newtons. The next part is saying what is the support force? So support force means find Fn. So now you have to work in the y direction. So it's got to be Fn plus the y component of Fa. Those two should add up to equal the mg. Now the Fa, I'm going to write it here. The Fa is 40 newtons, so this way I don't keep looking back. Okay, so this is just going to be Fn equals mg, and the mass is 6 kilograms. So that's 60 minus 40 sine of 50, and that should give us 29.36 newtons. If the coefficient of friction is 0.04, what's the force of friction? So you just have to do Ff is mu Fn. Now this is kinetic because you are moving. And that's going to be 0.04 times 29.36, and you should get 1.17. Not much friction. Okay, now with friction, what is the acceleration? So we just have to work in the x direction because we're going to accelerate horizontally. So my F net equals ma will be the x component of Fa minus the force of friction equals the mass times A. Well, this is 40 cosine of 50 minus the force of friction, which is 1.17, and the mass is 6 in A, and you should get an acceleration of 4.09. You guys want to come and say hi to the crowd?
Yeah.
All right. These are some of the soccer players, all right? Okay, say physics rules.
PD gotta take the L.
All right, number 52. You are pushing a 10 kilogram box. So you're pushing down. So here is the box. So you're pushing down this way. So this is the applied force. Okay, and you're making an angle of 20 degrees. Okay. I have to stop. All right, Danny, leave.
Lock the door.
All right. Now we have the mg. Okay, since you're pushing down, the ground has to support more, so it has to give you the normal force has to be bigger than mg. And the good thing here is that they're telling us how much friction there is. So that's just 32 newtons. What is the coefficient of friction? So the coefficient of friction is FF over Fn, because FF equals mu Fn. So I have to get the Fn, because the FF is already given. So that's 32. Now, where do I go get the Fn? I have to get that from the y statement. So for the y direction, Fn is the only force acting up. Fa contributes down with an amount of Fa sine of 20 plus mg is also pointing down. So if we do the math correctly here, now Fa is 40. So we do 40 sine 20 plus 100, because that's 10 times 10. So once you get that number, you throw it in here. That should be 113.68. And the whole answer should be 0.28. Okay? All right, number 53. A 40 kilogram crate is pulled. So we're gonna, the normal force should be less. We should know that. So here's my mg. I'm providing more support, so the floor does not have to give all the support. So Fn is less than mg. This is the applied force. Okay, I'm doing 53. This is 40 kilograms, which means the weight is 400 newtons. The applied force is 100. And the angle with the horizontal is 30 degrees. And they're giving us the coefficient of friction, which means there must be some friction. And it's asking us to find the acceleration. So I'm going to start in the x direction because that's where the acceleration is happening. So it should say Fa cosine of 30 minus force of friction equals the mass of the object times A. Now this is 100 cosine of 30 minus FF, which is mu. The mu is, oh, I'm looking at the wrong place. 0.06, okay, times Fn, which I don't have, so which means I have to go to the y direction and get it. The mass is 40 kilograms times the acceleration. So now if I go to the y direction, I can see that Fn is pointing up. The y component of A is pointing up, okay? And those two should add up to equal mg. So Fn is mg minus something. So it has to be less. We already know that conceptually. So it's 100 sine of 30. So this should be 400 minus 100 sine 30. That should be just 50. So this is 350. Put that in here. And you should get an acceleration equal to 1.64. Yep, that's what it is. All right, last one all day. All right, so a student exerts a force of 72 newtons along the handle of a lawnmower. So they're pushing down on the lawnmower. Okay, so I'm going to put that force here. This is the ground. Applied force here. That's 72 newtons. Here's the angle of 60 degrees. Now we know that the normal force is bigger because we're pushing down. So the ground has to provide more support than mg, than the value of mg, I mean. Okay. Okay, so there is friction. So they're not giving us the coefficient of friction this time. They're actually giving us the whole friction. So that's 15 newtons. Okay, find the normal force. So to find the normal force, I have to work in the y direction. So Fn is the only force acting up equals, now this Fa is going right and down. So that's equal to the down now. So that's Fa sine of 60 plus mg. So that's 72 sine of 60 plus, now the mass is 100, so plus 1,000, and we should get 1062.35 newtons. Now to find the acceleration is happening to the right, and the x component of Fa is contributing to the acceleration. Ff is holding you back, equals ma. So you always want to write your statements with no numbers, and then you start putting numbers in. So 72 cosine of 60 minus 15 for newtons of friction, and the mass is 100 times a. Cosine of 60 is half, so this becomes 36 minus 15 equals 100 and a. So what is that? It's 21 equals 100a. So your acceleration should be 0.21 meters per second square. Have a nice day.